In this video, I'd like to continue talking about finding the period of sinusoidal functions when we are given a picture of the graph. And remember, the period is essentially just the length, the horizontal length that the function goes through one unique repetition, and then every period, the function essentially repeats. For instance, we are told these midline values, and if we go all the way to this midline value here, over this section, the function is unique. It goes up, back down through the midline, down to a minimum, and then back up again. But if we continued it, it would repeat infinitely many times after that, and likewise for before it. Now, another way to look at the definition of the period is that it is the distance between two consecutive minimum values, or it's the distance between two consecutive maximum values. But in this case, we are told values about the midline. We are told that it intersects the midline at this coordinate and at this coordinate here. And from that information, we can figure out what the period is. Now, to go through one unique repetition of this curve, one period of the function, it will start at the midline, go up, come back through the midline, and then go down to a minimum and come back up again, once again passing through the midline, and then after that it will repeat. So the distance from this midline value to this midline value here, this would be one period, meaning that the distance between these two midline values, these consecutive ones, this would be half the period. So if we can figure out this horizontal distance here, then we can multiply that by 2 to figure out the period of this function. And we know the x value of each of these points, so we can just figure out that difference. We can take the larger one, which is at minus 5.5, and subtract the more negative one, which is at minus 10.7, to figure out the distance of this line, this length here. And we're subtracting a negative, so that's the same as adding. And once we compute this, we get a value of 5.2, meaning that half the period is 5.2. So if we want to figure out the period, we just multiply each side by 2 and figure out that the period is simply 10.4 units. And we can roughly check this by figuring out the x value of this midline point where it intersects here. We know it would have a y value of negative 3, but to figure out its x value, we take the x value at this midline point and we add it to the period. So we take minus 10.7 and we add the period to that of 10.4, and this gives us an x value of minus 0.3. And we can see that this point right here would very roughly have an x value of negative 0.3, which allows us to feel confident that this value we found for the period is correct. And from here, let's do one last example problem, where again, we're given this sinusoidal function and we need to find its period. Though in this case, we're told where it intersects the midline, and we are told one of the maximum points. So here's our midline point, and here's our maximum point. And keep in mind that over one period, it would go back through the midline. It would then go through the minimum and then back up to the midline again, meaning that this distance right here, this is one period, and the distance to this midline point in the middle, this is half a period. So if we look at this distance, this is half the period, and the maximum point is right in the middle of these two midlines. In fact, these functions, these sinusoidal functions, are quite symmetric. And if the maximum point is exactly in the middle of this length right here from one midline point to the next, then it's half of this length here, and this is half of a period. So the distance from this midline to the maximum is 1/4 of the period. So 1/4 of the period, that's equal to this horizontal distance here. Let me use a different color. It's this distance right here, essentially, to this x value of our midline and to the x value of our maximum point. And to find that distance, we can take the x value at our maximum point and subtract the x value at this midline point, and that would give us 1/4 of the period. And from there, we can just multiply each side of this by 4 to find the actual period. So we take 5/4 of pi, the x value of our maximum, and we subtract the x value of our midline, which is pi, though if we want, we can find a common denominator and rewrite pi as just 4 pi over 4. And 5 pi over 4 minus 4 pi over 4 would just be pi over 4. But again, this is 1/4 of our period. So if we want to find the actual period, we multiply everything by 4. We take pi over 4, multiply that by 4, and we can determine that the period is simply pi units. And one way to verify this is that we can look at this value of our midline, and if we take the x value here of this midline point and we add the period to that, which is pi units, then we should get back the x value of this point here. And if we take pi and add pi to that, this should be at an x value of 2 pi. It would still have that same y value of the midline, which is 2.75. And we can see that that's roughly true, since twice pi is roughly 6.28 units. And since this can be confirmed with the picture, we can feel fairly confident that this is indeed the correct value for the period.